Hello, today we'll start with module 3. Our first topic will be Taylor's theorem for a function of two variables. So over here, you have Taylor's theorem for a single variable, which is written in the form f of x plus h equals f of x plus h times the first derivative of x by 1 factorial plus h square times the second derivative of f of x by 2 factorial plus h cube times the third derivative of f of x by 3 factorial and so on. Now for two variables, you will have x and y. So you can take x plus h and y plus k. So here we'll have f of x comma y plus h times the derivative of x with respect to x plus k times the derivative of x with respect to y times 1 by 1 factorial plus 1 by 2 factorial h dou f by dou x plus k dou f by dou y the whole square plus and so on. Now we can take x as a and y as b, so this becomes a plus h and b plus k. And everywhere else you just replace x with a and y with b. Over here you are saying it's a function of a comma b. Over here you can call it a function of x comma y. That's it. Another note, this is not angle 1, it's factorial 1. This is factorial 2. This is another way you can write factorial. So one way is here, 2 exclamation mark, other is angle 2. Over here you can also expand your h times dou f by dou x plus k times dou f by dou y the whole square to a square plus b square plus 2ab. That's what I've done over here. Now you will have the third case where you take a plus h as x. So previously what we did, we took x as a and y as b. Over here we're taking a plus h as x and b plus k as y. So again we're back to f of x plus x comma y. We keep a comma b as a comma b. Here we'll have x minus a. H becomes x minus a, as you can see over here. K becomes y minus b. Dou f by dou x plus y minus b dou f by dou y. This is the form we'll be using the most. So this for question will come in the form expand f of x comma y in powers of x and y or in the neighborhood of the origin or any point. Origin will be 0, 0. Here we have an example. Expand e power x sine y in powers of x and y up to the third term, that is the third degree, using Taylor's theorem. So we know e power x sine y is your f of x comma y, and since here nothing is mentioned, it's not saying about any point or about origin or anything, we take it by default as origin, so we take 0, 0. Now by using Taylor's theorem, we have f of x comma y equals f of x comma y plus x times f of x. This is your another way of writing the derivative. I call it the shorthand of derivative. So fx 0, 0 plus y times fy 0, 0 plus 1 by 2 factorials. You expand your x plus y the whole square. So way you get this 1 by 3 factorial x plus y the whole cube. So over here you are taking a triple derivative. You will have two derivatives with respect to x, one derivative with respect to y, and so on. Now this is my personal way of doing it. You make a table. F of x comma y is e power x sine y. This is also technically in the form in the form as shown over here. Here your a plus h equals h, b plus k equals y, but over here you are essentially telling h equals 0. So you can take this table over here, e power x sine y. Now we are taking about origin, so we test the value at origin. For x as 0, you get e power 0 sine of 0. Sine of 0 is 0, hence you get 0. The first derivative. On taking the first derivative, you will have e power x sine y only, because derivative of e power x is e power x. F of 0, 0 is 0. F of y, so you're taking a derivative of sine y, becomes cos y. F of 0, 0 becomes 1. Same way you take a double derivative, with two derivatives with respect to x, one with x and one with y, 2 with y, 3 with x, 2 with x, 1 with y, 1 with x, 2 with y, 3 with y. And then all these values, this entire right hand side of the column you got, you take it and you submit it in the original Taylor's equation. On substituting it, you'll get f of x comma y equals 0. And then whatever you have, so your f of x 0, 0, which you know is going to be 0. As you can see up here, your f of x of 0, 0 is 0. So that's what you substitute up here. So it's x times 0. Like that, on substituting everything and solving, we'll get this as your value. Moving on to the next question. Use Taylor's series to expand x square y plus 3y minus 2 in powers of x plus 1 and y minus 2 up to quadratic terms. Quadratic we know means degree 2. So we have to take up to the second term. F of x comma y is given as this function. Now it's given powers of x plus 1 and y minus 2. Previously nothing was given, so we take origin. But here we are given values x plus 1, y minus 2. So we take x is minus 1, y is 2. So we need to find f of x comma y at minus 1 comma 2. That's what we do. Follow the same method. F of x, f y. So these are our first derivatives. The second derivatives, 2 with respect to x, 1 with x, 1 with y, and 2 with respect to y. On substituting, we get these values, like we solve it, and then we get put minus 1 comma 2 accordingly, and we get these values. Now according to Taylor series, we know this. This is from the third formula. F of x comma y equals f of a comma b plus x minus a fx a comma b, and so on. This is the expanded form where we have already performed a plus b the whole square. Here it's given that a is minus 1, b is 2. We can say from here, because those are the points which we need. So a is minus 1, b is 2. So and that we substitute over here accordingly, and then your f of x at a comma b we are taking from here. Substitute and simplify, we get this answer. Another example we take is expand tan inverse of y by x in the neighborhood of 1 comma 1, or we can say expand tan inverse of y by x using the approximate value of f of 0.9 comma minus 1.2. So taking an approximate value, we take 0.9 to 1 and minus 1.2 to negative 1. So essentially it's the same question. So here we write by approximation the point is 1 comma minus 1. We can say f of x comma y is tan inverse of y by x. Here x is 1 and y is 1. So we're taking, for solving for this, if we have to solve for this, we take x is 1, y is minus 1. Here by approximation method, x is 1, y is minus 1. The same way we solve it. So tan inverse of y by x, first derivative with respect to x, first derivative with respect to y, and we plug in 1 comma 1 to get the values. Same way we form the table we need. As we can see over here, the table we need, and then we can expand in this Taylor series formula. F of x comma y is f of a comma b plus x minus c times first derivative plus y minus b times second derivative plus 1 by 2 factorial x minus a square f times second derivative plus 2x minus a y minus b, second derivative with respect to x and y, this is second derivative with respect to x, and y minus b the whole square, second derivative with respect to y. On solving, we plug in the answers from this table over here, and then we can simplify it to get this answer.